This video will be covering using Descartes' rule of signs to determine the number of positive and the real number of zeros of a polynomial function. So basically what the Descartes' rule of signs is doing is not actually finding the solutions. It doesn't do that for you. It doesn't actually find the solutions. It gives you the possible characteristics of it. So this one is going to find your positive reals and your negative real possibilities. Okay, it doesn't actually find them, but it does give you some, it kind of zeroes in on what the solutions are going to be, or what types of solutions they're going to be. So let's look at the rule itself. The Descartes rule of signs says if f is a polynomial function written in standard form. Now remember, one thing he doesn't say here, the coefficients have to be real on this, but if f is denotes a polynomial function in standard form, the number of positive real zeros of f either equals the number of variations of signs of the non-zero coefficients of the function, or else equals the number less than that by an even integer. So what that basically is saying in another way of terminology is this. You count the number of sign changes from one term to the next. And let's say the number of sign changes was 4. So you went from plus to a minus, that's a sign change. Or you went from a minus to a plus, that's a sign change. But if you go from a minus up to a minus, it's not a sign change. If you go to a plus, that's not a sign change. So if f of x has, let's say, 4 sign changes, so you could have, if that's the case, you can have up to 4 positive real zeros. But it may not be 4. It could be 4 or 2 or 0. That's what that last blurb is saying. It says it could be equal to less than that by an even integer. So if you have 4 sign changes for f of x, you could have 4, 2, or 0. Now if you have, let's say, 3 sign changes, if you have 3 sign changes, then it could be either 3 or 1, because it's less than that by an even integer. So that tells you something. If there are 3 or 1, you know you're going to have at least 1 positive real zero in that one. So that's kind of useful. It's because if you know you're going to have 1, then if you find that positive real one, then you know you're not going to have another one. So that's what this is saying. Now on the other end, the negative real zeros, you'd have to evaluate f of negative x. If you evaluate f of negative x, and let's say there are 2 sign changes. If there are 2 sign changes for f of negative x, then you're going to either have 2 negative real zeros, or you're right if you say none. So it's always less than that by an even integer. So if you have 5 sign changes, it's going to be 5, 3, or 1. 6 sign changes, they're going to be 6, 4, 2, or 0. But again, this is not telling you what they are, what the actual numbers are going to be. It just tells you what the characteristics are going to be. So let's look at a really quick problem here. F of x, and it's negative 3x to the 7th plus 4x to the 4th plus 3x squared minus 2x minus 1. So there are a lot of terms that are missing. The x to the 6th term is missing, and x to the 5th term is missing. So we ignore those because it says the number that are equal to that in the variations for non-zero coefficients. So we really don't need to put that, the word about the 0 terms. So from negative 3x to the 7th to a positive 4x to the 4th, that's a sign change. And then from positive 4x to the 4th to a positive 3x to the 2nd, that is not a sign change. So then from 3x squared to a minus 2x, that's a sign change. So there's 2 of them right there. And then from negative 2x to a minus 1, that is not a sign change. So there were 2 sign changes through the list. So you're either going to have 2 positive real zeros or none. So you're not going to have exactly 1 in this case. You're going to have 2 or no positive real zeros. Now let's look at f of negative x. So you do the math. Negative 3 times negative x to the 7th plus 4 times negative x to the 4th plus 3 times negative x squared plus minus 2 times negative x minus 1. And when you do the math, there are no sign changes until you get to the very, very end. So 2x to a minus 1, there's only 1 sign change. And when there's only 1 sign change, that tells me something. That tells me that there is going to be 1 negative real zero. 1 negative real zero. So you're guaranteed to have exactly 1 negative real zero. So when you find it, and we will find the means later on to how to find these numbers, and once we do find it, then we know there's not going to be another one past that. So, okay, let's look at another example. So we're going to use the number of real zeros to determine the theorem, and then Descartes real signs. So using the number of real zeros theorem, let's see. Well, the degree is 5, so we know we're going to have up to 5 zeros here. Okay, real zeros, up to 5 real zeros. That's no more than that. Now, you will have exactly 5 zeros if you include the complex, like we said before. Okay? So let's look at the Descartes rule of signs. So if you look at the f of x, and you look through there, and you're like, okay, 5x to the 5th plus 2x to the 4th, that's not a sign change. And then 2x to the 4th minus 3x cubed, that's a sign change. So there's a sign change there. Where is the next sign change? It's not to the very, very end, negative x to plus 4. So there are 2 sign changes. So one between the second and third terms, and one between the final 2 terms. So what does that tell me? It tells me I'm going to have either 2 or no positive real zeros. So again, this doesn't tell me what they are. It doesn't tell me the actual number, what the numbers are going to be. But if I find one, then I know I'm going to have another, because it's either 2 or none. So if you find one, you know there's going to be another one. Okay? And if you found 2, you know there's not going to be any more than 2. Remember, there's up to 5 zeros here. So if you could have, there is a possibility that you won't have any, but you might have up to 2. But you won't have but just those 2 possibilities. And then you evaluate f of negative x, and it turns out to be negative 5x to the 5th plus 2x to the 4th plus 3x cubed minus 2x squared plus x plus 4. I want you to notice that when you evaluate f of negative x, only the odd degree terms will change signs. The even degree terms don't change sign. So it was only the 5x to the 5th will become a minus, and the negative 3x cubed will become a minus, and a minus x will become a plus x. All the odd degree terms change signs, but the even degrees do not. Think about why that's the case. So f of negative x has 3 sign changes. Okay, so what happens here? Therefore, there are going to be either 3 or 1 negative real zeros or solutions. So since there were 3 sign changes, it's less than that by an equal number. So what we could do is kind of put these together to get some possibilities. Because you remember that before that you could have up to 2 on that one. Okay, 2 positive real zeros. You could have up to 3 negative real zeros. And there's 5 right there. So you could have 2 positive ones, 3 negative ones, and that takes care of all 5 zeros. But there are other possibilities. Remember, you may not have any positive real zeros because it's either 2 or none. Okay? So if you don't have any, and you can have up to 3 negative real zeros, so you could have no positive reals, you could have 3 negative reals, which concludes the final 2 would have to be complex. So you could just kind of play around with the possibilities. You could say, well, what if there's 1 negative real? Well, if there's 1 negative real, and then there are 2 positive reals, then the remainder has to be 2 complex. But if you have 1 negative real, because remember you're guaranteed to have 1 negative real, and you don't have any positive reals, then that means the remaining 4 would have to be what? They'd have to be complex. Okay? So, like I said, this does, like I said, I keep saying it, this does not find the zeros for you. Okay, they will not tell you what makes this function equal to 0. But it tells you some possibilities. So when you start finding some, you can actually narrow down the other ones, or what kind of solutions the remaining ones are going to be. So you won't be looking out in left field for zeros that are not there. So, all right. So this concludes this video. And if you have any questions, as always, feel free to contact me. And you guys have a good day.